Hi everyone, my name is Gautam. I am the CTO and I run engineering for Ectron. We're here today to talk about our range of computers, and here with me is Kurt Vecchio, our senior software systems engineer and also the architect.
Today, going from right to left, we have our biggest and baddest computers and some of our embedded gateway computers. So starting on the right, this one's our ECT MAN server class computer. This one has an Intel Xeon 6 core. It also comes standard with 1 terabyte of SSD storage, which can be expanded up to 2 terabytes. It also starts at 16 gigabytes of DDR4 RAM. That can also be upgraded to 32 gigabytes of DDR4 RAM, and as well as a slew of different ports with quad Ethernet ports, quad USB 3.0 ports, dual USB 2.0 ports, and an HDMI port. You can have a lot of connections running both as a local database, running cameras through it, a lot of different options as well as the processing power. And even at that level, this computer is rated for environments to operate between minus 40C to 85C. So not only can it be on your factory floor, it can exist in harsh environments. It also has a lot of different connectivity options with Gotham, if you want to mention about some of the radios.
Sure. I mean, basically it has 7 expansion slots. So 2 of the expansion slots are used for SSDs, but other 5 you can put in different radios. So we include standard radios, for example, LTE-4G with GPS. You can put Wi-Fi in there, you can put LoRa in there if you want, and other things as well. And the expansion slots can be used to extend SSDs as well.
Mm-hmm.
So it's a very upgradable server class computer, which can be on the edge and be your gateway / gateway plus / storing databases like you mentioned. And we supply a full software stack as part of our Smart Eye solution, which goes on top of that, which connects to, can aggregate different computers that we show here, or can serve independently as well, hooking up cameras and doing image processing as well.
Yeah, we see a lot of good applications, people using it on the edge to handle real-time sensor data, as well as also having the power to send that data back up to their cloud instances, whatever data lake they may have there for further processing. But with its closeness on the edge, you can do a lot of real-time analytics as well as decision making. Along that same line, we have our next computer here, our ECT ECI. This one is also a gateway plus computer, as we like to refer to, not as powerful as this guy here, but a much smaller form factor. This runs with an Intel Core i3 chip, and it comes with 450 gigabytes of SSD. This also has 16 gigabytes of DDR4 RAM. That comes standard, and as well as the operating conditions, this one's also meant to work between minus 40C and 85C. So this can be out in the field. Again, it can be right on your manufacturing floor, right next to the greasy, dirty machines. It can withstand all that, as well as it has options for expansion slots for M.2 connectors. So one example is running an additional coprocessor, such as a TPU, if you want to run ML models directly on the edge and do inferencing there. You can also swap that out to add in a radio. So if you want to have 4G connectivity, if you need this deployed out in the field, you can put in a SIM to get it internet connection wherever you need it to be deployed.
In fact, we have a deal with Orange Telecom where we supply global 4G, LTE, or 5G SIMs that go, and the radios that go with these computers for your deployment. And then one thing, Kurt, I want to mention is all our boxes are Halt and HOS tested as well. So vibration tested, temp tested, run through temp cycling. So these are ruggedized computers that can be deployed in harsh environments. They all are rated to work from minus 40 to 85C.
Yeah, and a lot of use cases with these guys, if you have a big factory, you have a lot of different machines, these can be great as different individual edge nodes. All of our computer systems are meant to talk to each other, so they can all act as individual nodes that can aggregate further up the chain. So you may have 4 or 5 of these directly by machines taking in some sensor data, and maybe these aggregate up to a server class. So that way you can look at all of those wide frame analytics locally, as well as then pushing it up. But this can also act as a gateway, so if you don't need as much of a setup, these computers will work great. You can run databases on these as well, and you can store data and then use them gateway to push that up to the cloud.
So the last computer that I'm going to talk about is based on our, what we call an EVK platform. So the EVK platform is based on AMD's K26 SOM. And it comes with a radio as well, and multiple options like relays to turn things on and off. It has 2 PCI Express slots in the back to add expansion cards in there. And this is the hardware that forms the basis for our smallest computer. Smallest in terms of not in size, but in terms of processing power. So the smallest computer that we have has ports on it for expansion like Ethernet, USB, HDMI, and on the back you have interface for relays. So you can turn on and off about 5 actuators, and it has dual Ethernet ports. RJ45, triple mode MAC, so gig Ethernet, 100 base T, based on your network. This also comes with the software stack. So as Kurt mentioned earlier, all these computers aggregate up to each other. So this can be direct machine attached, so you can actually run a control loop and turn things on and off. And this can aggregate up to these computers, these can aggregate up to this, or they can be used individually as standalone. And all of them, like I said earlier, are rated for -40 to 85C. So whatever you develop on this, we can customize the enclosures, and also it can be deployed, or you can buy this off the shelf. It can be deployed in the field, and it's ready to go. It's ruggedized. It's basically for industrial applications or multiple applications that you can have, and all of them come with a software stack, databases, storage, expansion capability.
And on the customization piece, as far as developing, we also have a Raspberry Pi header on here as well. So in this case, we have a radio card from 6Fab, but you can also swap these out for any Raspberry Pi compatible accessories. So if you have a different application, you don't need that cellular connectivity, you can do that as well. And like Gotham mentioned, these nodes, they don't have to go specifically up, but you can have a couple of these machine mounted, and these cards also have expansion slots for running dual processors such as TPUs again.
Yes.
So these are
Yes.
great examples. If you have a machine learning model that you want to be running directly on the edge, you can be piping data directly to the computer itself, and with that coprocessor you can do the inferencing right there on the edge, and then with the relays you can have it change the parameters of whatever you're working in real time to make those adjustments.
So one of the first things when we started building these things is we looked at environment. So if you look at the stack, the latency stack provided, so these computers can do analytics within 30 milliseconds. Some of them even in microsecond, order of hundreds of microseconds. So if you need to shut down a machine and you have an alarm, so these would be very useful. So that's the whole idea. So you can do the cloud-based analytics and inferencing if you want. For non-real-time stuff, for hard real-time stuff, these computers are ideal because they can be deployed on the edge right
And they can really facilitate both of those. These can be used, you need to get that data up to the cloud platform in the first place. So these are a great tool to get it up there. You can build that huge repository of data sets to build those models on, and then you can bring those models right back down to this gateway box. So then now you're inferencing directly on the edge as the data coming in versus with the latency time of having it to go all the way up, process on the cloud, and then come back down before any correction is done.
The idea is you can scale up or down, so our solutions are meant for that. So from small businesses all the way up to larger deployments, like if you want to do, examples are if you have a large injection molding shop, you can have multiple number of these computers set up. Or if you have you're monitoring an oil and gas pipeline, or if you have a field monitoring required where you want to save truck rolls and the cost to do that, to repair, you can have these remote monitoring and be connected to the cloud. You don't need infrastructure, as Kurt pointed out. All of these have the capability to do wireless connectivity, and we provide the SIMs and the radios that go with it.
Well, thank you for watching this. I hope you learned a little bit more about the computers and products we have to offer, and we hope to hear from you soon.
Thank you.